Good evening. An Air Algerie plane has just crashed in northeastern Mali. There were 118 people on board, with no survivors. More on this after our latest weather report. Now on to Z for that report. Stay tuned.
Thanks, Dee. So, as we can see outside, it's not raining near as hard as it was a few minutes ago, which is good for all the pedestrians down there who are no longer experiencing the severe winds. Let's have a look at what the winds did look like, but first let's explain how a wind sensor works. So, as we can see, there are 5 wind sensors. 4 of them are placed in the formation of a square or a rectangle, and the 5th one's placed in the center. This allows us to collect data from a variety of different points within the wind field. So the following picture is the same as the previous one with these added wind lines. So we can't actually see wind outside, but if we could, maybe this is what it would look like. So on the top left corner, we see that there's one swirl hitting the flag. In the top right corner, we see that there's 2 swirls, but the swirls are going in the same direction as the one on the top left. So we can see that the wind near both these flags is going in the same direction, but that one of them is going to be stronger and faster just because there's more wind lines going through there. The other 3 flags that we see are going in different directions and different speeds again. So the one in the middle is going in a relatively straight line and kind of slow. The one bottom right is going in a swirl in the opposite direction, and again, relatively slow, right? The one on the bottom left, however, is going decently straight, and it's going faster because there are 2 lines. So now that we understand how a wind sensor works, let us have a look at the wind on the ground.
Dun dun dun.
So as we saw in the clip, all 5 sensors were moving in the wind. However, if you notice, the one on the bottom right moved significantly less at the beginning. This could be due to the fact that the wind was just not flowing through that area quite as much, or that it was a smoother and less wavy in direction type of wind. So there are lots of different reasons for the patterns. Now, as you see the video progress, the flags start to get more turbulent. And again, that's changing wind patterns, perhaps people moving out of the way so that the wind can access the flags a bit more easily. And we also noticed that closer to the pole, or the site of attachment, the flag is fairly steady, whereas at the tip, it's waving around very, very quickly and very, very sporadically. What does this tell us? This tells us that, one, we are anchored, and so it doesn't have very much space to move around. Second, that it kind of acts as a surface. So when a wind comes along, it starts on the surface and things are all right, and the further it goes along the surface, the faster the speed goes, creating turbulent flow. This can be shown in the following picture. So as you can see on the left side of the picture, there's laminar flow, so nice, smooth, orderly. And on the right side of the picture, it's all sporadic and spinning in every which direction. So that would help explain why our flags are moving in the way they are. So again, nice and calm near the root where the flagpole is holding them, and turbulent at the end where they're moving around almost too fast to see. So the equation that is currently on the screen is the Reynolds number calculation that is dependent, as we can see in the numerator, on the length of the material over which the fluid is flowing, so in our case the flag. Because it's dependent on the length, we can determine that at a certain point when the Reynolds number increases over a threshold, it will be turbulent flow, which again explains why at the end of the flag it's extremely turbulent, while at the root it is not. Sources of error for this project, or for this lab experiment, are the fact that there were pedestrians walking by, and that the movement of the air currents around them would have changed the wind flow through the sensor field that we had placed on the ground, which means that the data we were collecting would not have been the field that would have been experienced by pedestrians on a normal day.